Hey everyone, today we're going to look at momentum. So we're starting a new unit today. Today's lesson will be pretty quick, I think, so let's get started. Alright, momentum is... There's a couple different ways you can think about momentum. One way to kind of think about it is it's like, it's kind of like inertia, but inertia was just related to mass. Momentum is going to be inertia in motion, I guess you could kind of think of it. I'll put it in quotes because it's kind of like a can't-be sort of phrase. So it's like it's kind of like the amount of motion that an object has, and in fact, that's just another way that you can think about it. It's like the quantity of motion would be a good way to think about it. It's a term that you've like heard before. I would think. So if an object has momentum, it has like a lot of sort of like motion, or is like moving forwards. When you think of an object, like a physical object with a lot of momentum, you're probably thinking of like a massive, fast-moving object. And that's essentially what it is. Like a large object that's moving fast has a lot of what we would call motion, right? Has a lot of this motion idea. But this is just like a number that we can tack onto that. It's like a value for the amount of motion that an object has. So it's kind of this like strange sort of idea. But if I like this definition sort of the most myself. Like the quantity of motion, or the amount of motion that an object has. And it is related to the mass of the object and the velocity. And so the equation has both of those things in it. The equation for momentum is P is equal to mv. New equation. As always, if you need the equations for this unit, they're all going to be on the last page for you back here. We'll throw them in your notes at the front. P equals mv. So, m, let's start with the things we've seen before. M stands for mass. And the unit for mass is kilograms. V. V is going to stand for speed. I'm going to write speed / velocity, because again, they're kind of interchangeable. And we always measure that in meters per second. Which leaves P. For reasons that I'm not actually sure what they are, P stands for momentum. I guess M was already taken up by mass, and so this is a P, momentum. And the unit for momentum, well, if momentum is mass times velocity, then the unit is just going to be the unit for mass, kilograms, times the unit for velocity, meters per second. And so this is our unit, kilogram meters per second. Kind of a weird unit, but that's what it is. So there you go. Okay, now momentum itself isn't always like a super useful thing. It is the amount of motion that an object has, but typically we're interested in momentum because it can give us the speed or the velocity of an object. So if you divide both sides by the mass, so you can kind of play around with this, you get an equation that looks like this. V is equal to P over M. Where again, V is the speed or velocity, P is the momentum, and M is the mass. So we can use momentum to solve for how fast an object is moving as well. So again, both of these helpful, just for different reasons. This first one will let us find the momentum of an object, and the second one will let us find the speed of an object based on its momentum. If you can use this equation, then you're in pretty good shape for today's lesson. We're going to do 1 through 4 together, then I'll pause, give you a chance to try the rest on your own, and then I'll go over those, and that'll be good. Alright. Alright. Number 1, what is the momentum of a 100-kilogram football player traveling at 3.5 meters per second? Alright, so let's figure out what we're solving for. What is the momentum is what we're looking for. So we go back to our two equations. Which of these is solved for momentum? I think it's that first one. P equals mv. We know the mass is the 100, because, right, mass is always measured in kilograms. We know that the speed or velocity is the 3.5, because it's measured in meters per second. Looks like we're just going to multiply the two of those together, and you should get 350 kilogram meters per second. There we go. The momentum of the football player. 2. Which has more momentum, a 2,000 kilogram car traveling at 5 meters per second, or a 10 kilogram cannonball traveling at 110 meters per second? So what we have here is this really massive car, 2,000 kilograms, it's like 4,000 pounds. But it's moving at 5 meters per second, which is not very fast. It's like 10 miles an hour. And then we've got this 10 kilogram cannonball, which is like a heavy bowling ball type mass, traveling at 110 meters per second, which is like well over 200 miles per hour. So which of them has more momentum? This slow moving but large object, or this fast moving but much smaller object? Let's figure that out. We have an equation for momentum. It's P equals mv. We're going to do it twice, once for each object. And then we'll compare our answers at the end. That's a V. Okay, let's do the car up top. So the car had a mass of 2,000 kilograms and a speed of 5 meters per second. When you multiply those two, I think you get a value of, I got 10,000. 10,000 kgms, kilogram meter per second. Then for the cannonball, it had a mass of 10 and a speed of 110 meters per second. And when you multiply those two numbers, you get a value of, I got 1,100 kilogram meters per second. So which of these two objects has more momentum? I think it is the car, because we got a bigger number there. So even though the car is moving really, really, really slow, I mean, you could probably run faster than this. The car is moving really, really slow, but since it's so big, it has a lot of this motion. It has a lot of momentum. The really fast-moving cannonball is just very small, and so it has relatively little momentum. Number 3. A 5,000 kilogram train has a momentum of 20,000 kilogram meter per second. What is its speed? So now looking for speed, which means maybe the P equals mv won't be a great fit here. Let's try the other one, V equals P over m. Because again, it's solved for speed. So that seems to make some sense. P is 20,000. Let's see if we can get some zeros in there. 20,000 over a mass of, I think, 5,000. Okay, divide these carefully in your calculator. 20,000 divided by 5,000, I think, is 4 meters per second. So sometimes momentum is like an easier thing to measure than like the speed of an object is. So what we can do is we can just calculate the speed based on the mass, and you get 4 meters per second. Number 4, is it possible? Can an object have zero momentum? If it did, what would that mean about the object? Okay, let's think about it like this. P equals mv. We're doing m times v. If one of these values is 0, the momentum would be 0, right? Because anything times 0 gives you 0. Let's go one at a time. Can m be 0? Can an object have a mass of 0? The answer to that is no. If an object had no mass, it would not be made out of anything. It wouldn't exist, so, okay, the mass can't be 0. Can V be 0? Yeah, definitely, right? So, I would say that the answer to this is yes. If the velocity is 0, what is the object doing? Well, if an object has no speed or a velocity of 0, it is not moving. Which kind of makes sense given the definition of momentum. If momentum is the amount of motion an object has, then if an object has no momentum, it has no motion. Okay, so now what I'd like you to do is pause the video, stop it, and try numbers 5 through 11. Just a bunch of practice using the equation. If you get them all right, you're great. If you're stuck and having trouble, then keep watching the video. So again, pause now, give these a shot. Number 5, calculate the momentum of a 0.03 kilogram butterfly moving at 2 meters per second. Alright, momentum is P. So I think the equation that is solved for P would be a good fit here, as in P equals mv. Plugging in, the mass is 0.03 kilograms, so I'm going to go with a 0.03 for that mass. 2 meters per second, that sounds like the unit for velocity, so I'm going to throw that in as v. 0.03 times 2 is 0.06 kilogram meter per second. Let's fix some of that, and then we're all good. 0.06 kilograms times meters per second. There we go. Cool. So there's only two equations for this right now, and you're basically just going to find the one that works best. Are we solving for momentum or are we solving for speed? Keeping that idea, let's try number 6. An 80 kilogram runner has a momentum of 300 kilogram meter per second. Find the speed. Alright, well that was pretty straightforward. We're calculating the speed. So I'm going to use the other one, V equals P over M. V equals P over M. Alright, P, remember, stands for momentum. So P is the 300, because it says momentum of 300. M, the mass, is measured in kilograms, so that's going to be the 80. And 300 divided by 80 gives you 3.75 meters per second. There we go. 7. 0.05 kilogram bullet hits a target with a momentum of 7.5 kilogram meter per second. Calculate the bullet's speed. Alright, it sounds like we're calculating speed again, so let's use that same equation, because we're calculating the same thing. V equals P over M. Alright, V is what we're solving for. P is 7.5, because it says a momentum of 7.5, so that must be P. And then on the bottom we got a mass of 0.05. Alright, divide these carefully in your calculator. I got 150 meters per second. That should strike you as like a big number, 150 meters per second. If you double meters per second, you're like roughly in miles per hour. So it's like 300 miles per hour. That should strike you as a large number, but it's a bullet, and bullets move really, really, really fast. So that's okay. If you got like a person moving this fast, that's probably wrong. But for a bullet, you know, it works. 8. 2,400 kilogram truck is stopped at a red light when a 1,200 kilogram car speeds by it. Which has more momentum? Alright, I didn't give you either of the velocities here, so you can't just calculate the numbers. But let's think about the two objects. The 2,400 kilogram truck is stopped. And if something's stopped, it has no momentum. Now the car is speeding by it, so it definitely has momentum. And some momentum is more than zero momentum, right? So which has more momentum? The 1,200 kilogram car. And again, the reason for that is it's moving. It has more than zero momentum, but the other object has zero. It's not moving. Which has more inertia? Okay, so now we're going backwards a little bit to our forces unit. And I'm hoping you remember that more mass is more inertia. That's how you can tell if one object has more inertia than another one. It just has to do with mass. So which one has more mass? The 2,400 kilogram truck. So velocity is not a part of this inertia idea, but it is a part of the momentum thing that we're doing right now. 9. Calculate the momentum of an 8 kilogram bowling ball rolling at 5 meters per second. Alright, we're calculating momentum. We have an equation for that. It's P equals mv. Alright, P is what we're looking for. I think we know the mass is 8 kilograms, because mass is measured in kilograms. We know the speed is 5 meters per second, and 8 times 5 is 40. There we go. So once you're a little used to these, they start going a little bit quicker. Calculate the momentum. Alright, we have an equation for that. P equals mv. A little repetitive, but that's okay. Of a 15 kilogram dog running at 6 meters per second. Alright, so we've got a mass of 15 kilograms. We're moving at 6 meters per second. Looks like we're just going to multiply the two numbers to get 90. There we go. Last up, calculate the speed. Alright, so I think we're using the other one then. The equation that is solved for speed. Of an 1,100 kilogram car that has a momentum of 20,000. Alright, so it sounds like that momentum on the top of our fraction is 20,000. And then it sounds like the mass is 1,100, I'm sorry, so we're going to put that on the bottom. 20,000 divided by 1,100. You're probably going to need your calculator for that one, and I did. I got 18.18 meters per second. There we go. All set. So that's it. So momentum is, again, it's this amount of motion. The equation is this, P equals mv. You can use momentum to solve for a velocity as well. If that's what you're trying to do, then we'll use v equals p over m. And again, as long as you're okay with these practice questions, just kind of using the equation, then you're good.